Hey guys, so today we're going to be discussing how we can determine the area of a figure. And as we've been talking about, a figure is a polygon or a shape, but except today we're going to be talking about how much space it takes up or space is needed to cover that polygon or figure. So I want to show you an example here. So area again is the measure of the number of unit squares needed to cover a surface. So unit squares is the form of measurement that we'll be using today to figure out how much space something takes up or how much space is needed to fit inside of a polygon. So as you see in this example here, this rectangle has an area of 6 square units. That means 6 of our square units fit inside. So just to go over that, a unit square looks like this. It's 1 unit, 1 unit, 1 unit, 1 unit, all the way around. So a unit square is the type of measurement we will be using today. Let's take a look here. So there's a yellow rectangle here, and the form of measurement that we're using is the green square inch. The square inch that's represented by the green square. So we're going to see how many of those 1 square inch rectangles or squares we can fit inside. So what we're going to do today is look at this yellow rectangle, and we're going to see how many square inch squares we can fit inside to see how much space it takes up. What is the area? Again, the amount of space something takes up or how much we can actually fit inside. So let's take a look. So if we were to start, we're going to take the 1 inch square tiles and see how many we can fit inside of our yellow rectangle. We can start making connections with symmetry. So if we know we can fit 1 or 2 or 3 square inch units on one side of a rectangle, we know that a rectangle is symmetrical. That means we can fit the same amount on the other side. So let's take a look here. So far we have 1 and 2 on one side, and then you see the others on the other side. We also can put some in the middle because they fit, but I do notice something. In order to find the area of a polygon or of a figure, it has to cover the entire space. So I do see that there are some gaps here, and those gaps can't be there. And we need to figure out how can we fill in those gaps. So yes, all 6 of these square inch tiles fit. Do you think that's the area? It's not, because we cannot have any parts not covered. So no, this is not the area of the rectangle. So let's start thinking, what if we tried it again, but we just tried to cover the gap? So if we started covering it the same way by inputting these rectangles right back in, the square inch tiles right back in. So we put 2 on each side. We're going to put 2 down in the middle. And now what if we just take more tiles and just start sticking them on top? That really doesn't help us measure, because all of our units of measure need to be exactly the same. So if I'm only using a piece of a tile or a piece of a square inch, it's going to be a little bit tricky to figure out how much in total I used. So no, there aren't any gaps, but there are some overlaps. Do you see where the squares are overlapping? And a good way to tell is by looking here in the rectangle. All of the units of measure should be exactly the same size, but this square to this square to this one are each different sizes. So if there are overlaps, as you see here, we cannot use that as an accurate way of measuring area. So if we're thinking, okay, well, I use 10 square inches, the area must be 10 square inches, that's not correct, because we can't have any overlaps or any gaps. So let's try it one more time, but let's try starting from the corner and making each of the squares connecting. So far, so good. Do we see any gaps or overlapping here? Nope, we don't. Do we see any overlaps? Nope. So do you also notice how all of the squares are represented exactly the same? We didn't overlap, we didn't leave any gaps. So the correct area for this rectangle would be 8 square inches. So let's try to find the area of this figure. So each square is 1 square unit. So really all we need to do is count. We need to see how many of these squares took up this figure. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total number of squares that took up the inside of this figure is 12.